All right, do one last little quick video for this section. It should be done. Just 3 pages, I believe. And so basically, we're going to look at inverse trigonometric functions. The six basic trigonometric functions in general do not have inverses since they are not 1 to 1, meaning we can plug in one value and get multiple results. So what we have to do is restrict the domains of them in order to make them 1 to 1. So for sine, we can restrict the domain like that, and that makes it 1 to 1. If you restrict it, you can't just do any interval of pi because, for example, if we were looking at this part of the function, if we tried to restrict it from 0 to pi like we did here on cosine, this would not be 1 to 1. Okay, so the restrictions are meant to keep them close to the origin, close to the y-axis, but also make them 1 to 1. So the restriction for sine is negative pi over 2 to pi over 2, so you either need to memorize that or remember how to draw the picture and look and see where I can put it there. The cosine domain is 0 to pi. The tangent domain is just going to be one of its full periods, whereas for sine and cosine it was half a period. It's going to be a full period, negative pi over 2 to pi over 2. And then the reciprocal functions, we can restrict their domains, cotangent, 0 to pi, secant, from 0 to pi over 2, and then union with pi over 2 to pi because we can't go across that. We can't have it have a value at the actual asymptote. And then the domain for cosecant is negative pi over 2 to 0, unioned with 0 to pi over 2. And again, the asymptote at 0, we can't have that be a value. And then what we can do is actually look at our inverses of these functions. You notice that, like if I take this one and I draw in the x equals y line, and then I draw in the, and I try to draw in the sine function, they're going to be mirror images of each other across that line, just like we'd expect for inverse functions. But there are all the inverses, and you either need to know how to invert the functions or how to come up with them. And again, here's x equals y, and here is our cosine function, right? So they're like mirrored imaged across that for all of them. So make sure you know these, make sure you have them memorized, make sure you can either come up with them or have them memorized, but be sure you know them. Now again, be very careful for looking at these here. This little -1 right here does not mean 1 over. It's not that. Okay, that just simply means, just like with the inverse functions, that's not the eraser. Just like with the inverse function, that just means it's the inverse function. It doesn't mean reciprocal like it does when you're talking about putting it on just a regular number for multiplication type purposes. Okay, so be careful of that. Not mean reciprocal. The graph of y equals and what we call this is arcsine, is symmetric about the origin. So yep, this one is, so we have arcsine, arccosine, arctangent, arccotangent, arcsecant, arccosecant, so you just put arc in front of it, or a lot of times, sometimes just people will say inverse sine, inverse tangent, inverse cosine, but you have to know when you say arccosine or whatever in front of it, that's what they're talking about. So the graph of y equals arcsine of x is symmetric about the origin. Therefore, the arcsine is an odd function. Okay? So arcsine is an odd function, just like sine was. Okay. So next, the arcsine and arccosine functions. Y equals arcsine of x is the number in negative pi over 2 to pi over 2 for which the arcsine of the sine of theta, or some variable, is equal to just theta. All right? That's what this is telling us. The arcsine of the sine is just theta. And then the same thing for cosine. It's the number in which the arccosine of the cosine in that interval is just our angle there, okay? You have to be careful though, because what your calculator will do is always go back to that interval. So if you give it if you take the arc sine of the sine of something that's outside that interval, it's gonna drop you back and give you the answer that was in that interval. So be very careful with that kind of stuff. All right, so find the exact value of each expression. The arc sine of -1/2. So if we look at our unit circle, we're basically asking ourselves, hey, when does sine equal -1/2? Well, sine values are our y values, and the y values are negative all on this bottom half of the unit circle. That's where y is negative. So we need to be somewhere down there. And so then we need to look at the coordinates of some of the points that are there. So if we look just at our standard old first quadrant things, we have those three places. We have the 45-degree one, we have the 30-degree, the 45, and the 60-degree one, or the pi/6, pi/4, and pi/3 ones. This one has coordinates of √3/2 and 1/2. This is √2/2. This is √2/2. This is 1/2 √3/2. So we need to look at anything with 1/2s. Well, we have a 1/2 right here, but that is for the x value, and we're looking at sine, so we want y value, so we're not interested in that one. But this one right here, there's a 1/2 on it, and it's a sine value. So it's the pi/6's ones, or the 30-degree ones. Those are the ones that we're going to be interested in here. So if I come along and I take a look in the bottom half, I'm going to have two of those. I'm going to have one right here, and I'm going to have one right here. Okay? Those are both our 30-degree ones. This one has coordinates √3/2 and -1/2. Hey, there's a -1/2. That's just what we want for sine. But this one over here has coordinates -√3/2, -1/2. Hey, there's a -1/2 that we want as well. So we have a -1/2 and a -1/2 there. And that's what we are interested in. And so now what we need to do is figure out, well, which one of these is going to give us an answer that's inside what we want for this. And so notice we're supposed to be between -pi/2 and pi/2. All right? And this one over here on the left, this is 7pi/6. All right? It's pi/6, 2pi/6, 3pi/6, 4pi/6, 5pi/6, 6pi/6. That's 7pi/6 right there. All right? That's definitely not between -pi/2 and pi/2. So 7pi/6, 8pi/6, 9pi/6, 10pi/6. This one's 11pi/6. That's also not between -pi/2 and pi/2. So are we at a bit of a loss? And the answer is no. What we have to do is also think, remember, look at this one. This side, this is negative, which means we can also rotate in the negative direction. So what we're interested in is not a counterclockwise rotation. We're not interested in the positive angles, but look at this. If we go this direction, our angle then is -pi/6. And that is in the range, it is right here in between the -pi/2 and pi/2. All right, that one works. And so then there is our answer. Okay, I'm going to leave arc cosine of 0 for you to try. Just note that arc cosine just means arc cosine like that, okay? So give that one a try and see if you can figure out where that one is. And again, pay attention to this up here, and I'll put the answer for you in the notes. It's pretty simple, so don't go too crazy with it. It's like 1 or 2 little lines. Just draw the unit circle and find it. All right, identities involving arc sine and arc cosine. So simplify the following expressions. So we have arc cosine of 1/2 plus arc cosine of -1/2. And we're supposed to simplify this. Well, arc cosine of 1/2, all right, we go to our unit circle, and when we get here, we need to figure out where is cosine 1/2. Well, cosine is 1/2. If we look back, I already drew it over here. Right? Cosine is 1/2 right there. That's at pi over 3. So if we go right here to pi over 3, this is 1/2 square root of 3 over 2, and that's at an angle of pi over 3. So arc cosine of 1/2 is just going to be pi over 3. And then we have arc cosine of negative 1/2. Well, remember, all our cosine values have to be where? They have to be between 0 and pi. That's where we're looking. And so we come back over here, oops, wrong button, and we say, all right, well, where do we get negative 1/2? Well, that's going to be here, and that's going to be here. But again, this is the only one that's inside what we need for cosine, our limited domain. So this one is negative 1/2 square root of 3 over 2, and that angle is 2 pi over 3, right? Pi over 3, 2 pi over 3, counting around. So this becomes 2 pi over 3. So we have pi over 3 plus 2 pi over 3 equals just pi. And there's our answer. All right? I'm going to leave B for you to try, but I'll put it in the notes for you to look at. So try it and then take a look at what's in the notes for the answer. Thus, from part A, here we can say that the arc cosine of R plus the arc cosine of negative R equals pi. And this will end up just being true for any of them. And so this is an identity, and it tells us that arc cosine and arc cosine of negative x are what is called supplementary. They add up to pi, or 180 degrees. And from part B, what you'll find out is arc sine of R plus arc cosine of R is gonna equal pi over 2. So you're basically gonna get the answer there, but try and do it anyway. And this tells us that arc sine and arc cosine are complementary, meaning they add up to 90 degrees or pi over 2 radians. All right, that's pretty much it for this. Finish up that problem and take a look in the notes to see the answers. All right, take care.